All right, so Unit 6 is all about volume and capacity. We'll talk about that later, and weight. This learning goal, though, I can find the volume of a prism is, of course, all about volume. So a little vocab for you to put on your fresh new page in your math journal. You're going to want to write down what exactly a cube is. And you have a nice picture over there, but basically it's a solid shape that has 6 square faces, all equal in size. So you'll see like we're pointing at that red one right there, but then there's also that blue one, the green one, and then there's 3 that aren't visible in this picture. So there's 6 total. Then you're going to want to mention that there's 8 vertices or corners. And so we're pointing at those.
The mathy word in the corner.
And then 12 equal edges, and you'll notice that those lines right there that we're pointing at are the edges. So just jot that down a moment, and you should be good on what a cube is. Now we want just to start thinking about how to find volume, and one way to think about that is you're already familiar with area, and how if you look here, we're looking down below, and there's it's 3 centimeters long.
I
feel like I'm talking without anything. It's 3 centimeters long and then 2 centimeters wide. And we know that in order to figure out area, we would just do 2 times 3 equals 6. Or length times width equals 6 here, in this case. The big idea with volume then is just tying in also the height. And so you want to think about, okay, I have this one layer here, and I have 6 cubes total. Then when I tie in this idea about figuring out the height, now I just am doubling those layers. And now instead of 1 layer, I have 2 layers. So instead of 6 cubes, I now have 12 cubes.
6 and 6, just stacked on top of each other.
So with this visual and just what we were talking about, we want to give you a moment to think about, okay, well, what if I just stacked on another layer here? How many cubes would I have then? And then what if I stacked on 1 more layer? And I think, 1 more layer. So just take a moment and think about, okay, how many cubes would I have total for each of those layers? So once you have those, if you need to pause, please do so, because we're just about to share those answers. But this is what you should have gotten for 3 layers, 18 total then. 4 layers, you should have 24 total. 5 layers, you should have 30 total. What do you notice, Mrs. Bush? What's happening?
Seems to me that each time we're going up by 6, which makes sense because each layer is 6 cubes.
Exactly.
Hopefully you're all seeing that too.
We're going to take a peek at, this is one more vocab word to look at, and that is volume. Is that you?
Me. That's all right.
Oh, go for it.
So volume is, and we've already sort of talked about it a little bit with that last example, but volume is just the amount of space that's occupied by a 3-dimensional object. So in the first vocab we talked about was a cube. The last 3-dimensional object we talked about was a rectangular prism. Those are the ones that you'll really focus on, but you could find the volume of any 3D object. You can find a cylinder, sphere, whatever. So please, in your journal, write down the definition of volume. So you should have the definition of a cube, definition of volume, and we'll move on to some examples of how to find volume, because there's actually an equation that will help you. So in this example, it should look a little bit like what we just did, only taller, different dimensions. So we've got a length, a width, and a height. So if we were trying to find the volume of this cube, we could find the length times the width and then add that together 5 times, but that seems like a lot of work. A lot of work when there's something easier we could do. So we are going to talk through the equation of volume, which is length times width times height. So length times width times height. oftentimes you will see that just written as L times W times H, but we want you to know what those all stand for. So in this case, if we look at our picture, we've got a length of 4 times a width of 3. 4 times 3 is 12 times a height of 5. So when we do all that all together, we have 4 times 3, our width, times 5, which should give you a total of 60 cubic centimeters, or 60 centimeters cubed. Hopefully you are noticing this 3, which is a little bit weird. You've not seen that before. We've seen squared when we were talking about area, but again, area, you had 2 dimensions. Cubic, we have 3 dimensions. So hopefully you're noticing that it is a 3, meaning 1, 2, 3. So when you say that, you would either say 60 centimeters cubed or 60 cubic centimeters. Either one means the same thing.
Now, one question I have is, if I wanted to do 4 times 3 equals 12, but I don't know my 12s that well, and I'm doing 12 times 5, can I mix up the numbers and do like 4 times 5? Because that seems easier to me.
Well, let's see. 4 times 5 is 20. 20 times 3 is 60. So, yep,
Yay.
that's one of the properties of multiplication is you can mix them all up.
So now that you are a little more familiar of how to solve volume, we want you to pause and try to solve this one. So think about the formula, think about what to plug in here, and we'll see what you get.
And try and write out your equation. Like actually write out the multiplication that you're doing. It's a good habit to be in.
That will be helpful when you meet in your groups.
And label your answer.
Yes, please. All right. So this is what you should have come up with, and I was just sort of laughing because I just realized, oh yeah, this is what we were just talking about. We just mixed the numbers around. 5 times 4 equals 20, times 3 equals 60 cubic centimeters, or centimeters cubed. So that one should be nice and easy. But let's have you try one more on your own. This one you for sure want to label, write down, and this one you do want to share in your discussion group because we're not going to share the answer this time.
Nope, and we're only making you do one, so lucky you.
So lucky.
All right, we shall see you tomorrow.